Hi, I'm Jake Kouns, CEO of Risk-Based Security. Welcome to this edition of The Right Security, the show which we spend time talking with leaders and veterans in the security space, tackling the issues of the day. Hello, today I'm joined by Steve Springett. Steve's a senior security architect at ServiceNow. He educates teams on strategy and actually specifics of developing secure software. If anyone knows Steve, he's really passionate about helping organizations identify and reduce the risk from third-party and open source components. He's an open source advocate. He leads several projects, including the OWASP Dependency-Track project, the OWASP Software Component Verification Standard, SCVS, and also CycloneDX, Software Bill of Material specification. I've known Steve for several years now. And from my standpoint, I think he's at the forefront pushing the need for this software bill of materials stuff, SBOM, before really a lot of people were talking about SBOM. So Steve, while we could cover a lot of things today, as usual on this show, I was thinking, why don't we talk a little bit about SBOM? We can talk then specifically about CycloneDX, and then maybe dive a little bit deeper into Dependency-Track project. So, welcome to the show.
Yay, thanks for having me, Jake.
Awesome. All right. Before we get into our specific conversations, I was thinking recently that a lot of people don't really know what they're talking about when it comes to all these sort of DevSecOps terms these days. It's getting a little confusing. So I was hoping that maybe we could get a moment, maybe if you can help us out here, define a few terms for our viewers. Specifically, I'm thinking about SAST, DAST, IAST, is that what we're calling it now, right? SCA, SBOM, there's probably a heck of a lot more, but why don't we do this? Why don't I throw one at you? We'll go maybe one at a time, and you can sort of define and explain maybe each a bit, and then maybe give us a concise, like, this is what it is, just to help sort of clear things up. So let's start off with SAST, Static Application Security Testing.
Absolutely. So when developers are writing software, they are using libraries, they're using SDKs, and they're writing a lot of original code. And you typically want to use a SAST, a static analyzer, to analyze the first-party code that you are writing, and specifically with the intent of trying to find security defects. You can find all kinds of other defects, performance and usability and all kinds of other things, but when we think of SAST, we typically think of security-specific defects in the first-party code that we are writing.
Perfect. All right, thank you. All right, so now if we think about DAST, DAST, Dynamic Application Security Testing. What is that?
So once you've actually built some software and you have it running in a, not even in a production way, but just even in a staging environment, it's running though, and it has realistic data. You can perform security testing during runtime. And specifically for web apps, where we're testing the web interface and maybe some REST APIs, that sort of thing, that's dynamic analysis. So it's testing security operations, looking for cross-site scripting and various types of injection attacks while the application is actually running. DAST is interesting because it ties into a lot of QA initiatives, Selenium scripts, and that type of testing that QA teams typically do. So there's really a lot of interesting touch points that security teams can have with regards to the development teams and specifically QA.
All right. Now the next one is, I guess, relatively newish. IAST, right? And IAST. And I guess people are saying IAST, Interactive Application Security Testing. What is this, and why is it different than the first two we talked about?
Yeah, it's kind of a really interesting mix between static analysis and dynamic analysis. It's looking at the application at runtime, but it's looking at the entire stack of what's being called and the variables that are going into the various functions are methods. So if, for example, if you have a web app and you throw some input at it that might, you know, that might affect like a SQL injection, for example, an IAST tool is kind of sitting in the middle at runtime, and it's looking at that input coming in from the application and then seeing how that is actually used in the call graph. And if it's actually used, for example, in a SQL statement, then that's something it could potentially find as an actual vulnerability, not necessarily something that's theoretical, but something that is truly a problem.
Gotcha. All right. What about SCA, software composition analysis?
Yeah, lots of acronyms in the security business, isn't there? So SCA is really looking at about the third party and open source components that that we are using. Typically, SCA is looking at either binary analysis, where you're actually looking at the artifacts themselves, or you're looking at the manifest. This is like the package.json or pom.xml, and trying to figure out what components am I actually including in the application that I'm building. This is really important because reinventing the wheel is very expensive, and we typically rely on a lot of third-party and open source components, so that we don't have to reinvent the wheel. We don't have to create our own persistence layers. We don't have to create our own authentication frameworks. We don't have to create our own web services frameworks either. So we build upon all this open source, but in doing so, we're actually taking responsibility for other people's code, and SCA can help us identify that kind of risk.
All right. So SBOM, the last one, SBOM, software bill of material. What are we talking about here?
Yeah, we're talking about inventory, really. And when you say it like that, it doesn't sound really sexy at all, right? Inventory. But that's actually a really hard problem. SCA tools, most of them don't get accurate inventory. Their goal is really to identify risk, not to necessarily produce the most accurate inventory. And in the case of SCA, sometimes being good enough is fine, because that's your goal, right? To identify risk. But you know, SBOM is really about the inventory. What is the actual components that I'm using to make up my application? It's third-party components, open source components, first-party components, who made it, where I got it from, who my suppliers are, if I made any modifications to those components, what those modifications were, who made them, and why. And you can also describe services. For example, if my application is a mobile app, and I use if I call out to the Google Maps API, for example, that might be a component that I can describe in my SBOM. But primarily, it's about software and the dependency relationships about that software. So I like to think of the SBOM as actually like an automotive, a dashboard in a car, right? Where you've got this dashboard, and that's an assembly. And then within that assembly, you might have sub-assemblies, like the instrument cluster, for example, is an assembly. And within that cluster, you might have a speedometer and a tachometer and all these other sub-assemblies. And within there, you have more finite components. You have capacitors and resistors and LEDs and all these other things. And that's kind of the hardware equivalent to like a software bill of material, where you're actually trying to describe what the inventory is in very complex systems.
So in listening to that, I got to ask you a question. I think it's one that, I don't know, it might not be tricky for you. You're good at this stuff, but I've seen so many people right now interchanging SBOM and SCA that sometimes I don't know if anyone really understands the difference, or they're part of each other, or we're just making up new acronyms. So if I asked you, what's the real difference between SBOM and SCA? How do you describe that? How do you explain to someone so they can latch on to use those words properly and better understand?
That's a great question because I actually run across the same misconceptions, I guess, all the time. So SBOM is really a way to describe what your inventory is. SCA solutions are one of a few different ways to be able to achieve that. They're not the only way to achieve a software bill of material, but a lot of organizations have already adopted SCA, so they already have SCA tools in place, and SCA tools can produce SBOMs, but they're not required to. You can produce SBOMs in a couple of different ways. The way that I personally like to produce SBOMs is not using SCA tools. I like to produce SBOMs as part of my build itself. So you're not actually relying on SCA tools to essentially guess what your components are. You're actually asserting what your components are through your build pipeline. And that's really an important distinction that um, for people that are new to SCA and SBOMs in general, it's one of these distinctions that you don't realize that's important until you're having these conversations much later in the process.
No, that makes sense. I was talking with someone recently, and the wording of manifest came up, and they were getting really confused about what is SBOM. Is a manifest part of an SBOM approach, or is manifest part of SCA, or both? And I think in some ways we're starting to confuse people, right? When we have all these definitions out there, people are really struggling with what tooling they need, and also sometimes relying so much on tooling they forget about concepts of what they're, the problems that they're trying to solve. So let me ask you this. I know you're a passionate guy. You don't always show it sometimes, but why do you feel so strongly about the importance of SBOM?
It's been something that I've had requirements for this since 2013. So this is not new to me. And I guess I'm passionate about doing it because there wasn't any commercial or open source tools available at the time that actually met my requirements. Back in 2013, I had a very simple requirement. I was working for a French software company, and we were producing these server appliances. These were things that we would sell into customers' data centers, and we would call them antiques now, but that was the model. And I had to control, I had to know like the operating system and the BIOS and the device drivers and firmware and the OS and the OS packages and, oh yeah, the application and its libraries. I had to kind of be aware of everything that we were delivering. And guess what? SCA didn't help me with that. In fact, SCA wasn't really around back in 2013. I had to kind of create that inventory by myself. And Dependency-Track was kind of the result of this need to be able to describe that full stack inventory of the thing that I actually cared about. Now, we don't have server appliances today, but we do have cloud native, this multi-stack thing that's running on other people's computers. That's kind of important nowadays, as is IoT, which is just a smaller variant of the stuff that I cared about back in 2013. So it's interesting that the problem that I was trying to solve back in 2013 has, well, essentially kind of exploded with the advent of cloud and the explosion of open source and now IoT devices. So it's really interesting, and it's something that I've been passionate about just because nothing was really around that met my requirements.
Makes total sense. And with your background of working at these companies and trying to solve these issues, and then we'll get into some of your other projects. But yeah, all right. So I want to ask this: in July of 2018, The NTIA started their next, or I guess the current one, but they had done one prior, but another multi-stakeholder process, and this one was for software component transparency. And in the very first meeting, Alan had reached out to me because I was actually talking his head off about this the prior year at a conference about how I was hoping someone could get involved with helping package identification because of all the problems with CPE, and well, that's for another talk. But I was actually in DC for the first meeting, and I wrote up even a blog on that, all my thoughts there. You know, the interesting thing was it was so vulnerability focused that a lot of people weren't even really, they were trying to talk about sort of the, identification of software and all that, but it all just kept coming back to vulns and vulns and vulns. And I thought that was a huge takeaway. But I was hoping to see you in person, but you weren't there. And so I was disappointed. And then suddenly your voice like chimed in over the, the speaker you called into it. Now, while I have just been keeping a pulse on things, it's my understanding that you've been quite involved with this process as it going forward. Is that the case? And from your standpoint, how are things going? What's going on here with this process?
Yeah, I think it's I got to give Alan a lot of credit. It can't be easy. Alan Friedman, who kind of leads this entire effort, the amount of times he has to say multi-stakeholder process, you should get a medal or a cape or something for that. When you're bringing together such a wide variety of people, I mean, he's got folks from the cloud, he's got software providers like where I'm from, he has automotive and national defense and medical and energy and all kinds of various industries, and they all have a seat at the table, and that in itself is a tremendous accomplishment. But I think we're making progress. In fact, I think the technical, I don't believe there are any technical limitations of supporting most of the use cases that exist today. So if you want to do license or intellectual property or vulnerabilities or other kinds of security things, or even forensics, I think the specifications, and there's a format group that just deals with the various formats that I'm involved with. It's I don't see any blockers right there. It's been a multi-year thing. We're in I think our second year now. I think of this, and there's a lot of really hard problems that exist. Some of the hard problems is naming, right? Naming is just an inherently hard problem. You mentioned CPE, and yes, we could have an episode dedicated just for that. But excluding CPE, just naming is hard. The National Vulnerability Database, the way it's positioned now, and even how it's trying to get into SWID is also kind of a concern to its future relevance. There's a lot of hard problems, and we're trying to tackle some of them as they relate to the SBOM efforts that we're working on. But there's been some really interesting POCs as well. I mean, the healthcare group recently had a POC. They're in the second phase of that, I think. There's an energy POC that's just getting started for folks in the energy sector. So there's some really interesting efforts that are ongoing, and it's really interesting because the specifications that were initially recommended have kind of changed position-wise because it's been such a long process already. So we went in with like two specifications, and we came out with essentially two different specifications. They're not the same. Standards evolve over time, and while we're going through this software transparency process, the formats, both SPDX and CycloneDX, have both evolved, and in some cases quite substantially.
Yeah, I remember sitting there and everyone wasn't sort of positioned in the room on their sides, but it became sort of apparent pretty early on of people had already picked their standards and what they were doing, and they were, this is what we do and we're not going to change. And so it is great to hear that the stakeholder process, and to your point, the multi-stakeholder process, you know, it's painful, but it can be very productive if people sort of lower their guard and try to think about maybe what's best moving forward, and that may sometimes be change. Now, I do think I remember one of the things that you had said, because it wasn't being discussed originally, was when you chimed in from above, you were talking about CycloneDX. Now, CycloneDX, I believe, I think you created this as a prototype around 2017. Is that right? Around that time frame?
Yeah, that's right.
So you've been thinking about this stuff forever, maybe from 2013 or maybe even before that. But CycloneDX came out as that prototype in 2017. So can you, for people that don't know what CycloneDX is, can you tell us what is CycloneDX?
Yeah, that's a great question. So CycloneDX came out of the need to make the inventory that I was making back in 2013, to make it portable and to make it automatable. I didn't want to manually do things. I wanted everything integrated with the build systems and that sort of thing. But CycloneDX is one of two viable, in my opinion, two viable software bill of materials standards. The other one is SPDX from the Linux Foundation. Both of these standards come from different perspectives. SPDX came from a license and intellectual property background, and CycloneDX came out of a lot of the work that I was doing at OWASP. So it's very security focused. And yeah, it was originally created in 2013 or 2017. I think the first release of that was first quarter of like 2018, I think. So by the time the NTIA meetings were already kicking off, I already had tens of thousands of people using CycloneDX at that point. So it was one of these specs that came in a little late, I guess, in terms of like the NTIA process, but its growth has dramatically accelerated over the last couple of years. In fact, it's more popular than the thing I originally created it for, which was the intent. I just didn't know if I was going to be successful in doing it or not. But it is my largest, by far, open source project. So it's security focused. The standardization process takes a risk-based approach. So instead of taking a very slow, drawn-out standards process to try to craft the perfect standard, security doesn't work like that. You know, you're never going to get in the door with security folks if that's the process that you take. Security is very iterative, just like the development teams that we serve. So we're focused more on, CycloneDX is focused more on continuous improvement, providing as much risk identification and to the adopters of CycloneDX as quickly as possible. And we also encourage innovation through what we call extensions, because the specification is extensible. So that allows you to create new things. If you have company-specific things that you want to describe in your SBOM, or if there's an industry vertical that does something that no other vertical does, well, you can create extensions to add additional capabilities to the specification, and those extensions can have a life of their own. They can go as fast or as slow as you want them to. And the interesting part about the extensions, it actually encourages competition. We actually have a little bit of competition going right now with a vulnerability extension. We've got a vulnerability. We can describe vulnerabilities in CycloneDX today, and there's a competing way to do that being proposed by another SCA vendor as we speak. So it's really interesting that the whole risk-based approach to standards development has really served CycloneDX very well.
Well, if you're going to talk about risk-based or risk-based security, I'm going to be loving on it. So, big fans of CycloneDX and the approach there. So if someone's watching this and they've heard SWID and they've heard SPDX and maybe several others. How do you tell them, what's the pitch to say, take a look at CycloneDX? Because I know you have a community that's growing, usage is growing, you'll welcome people in, but some people just sometimes when they're not used to something new or the way they do it, it's hard to say, well, what's broken about what I'm doing? What's the quick pitch of why it's different than those other ones?
I think it's full stack. So you can describe everything from device drivers to containers to entire operating systems to it's not the best, but it does hardware too. So if you're shipping an IoT device, you can describe that thing. Or if you're shipping an MRI machine with 3 different software stacks embedded in it, you can describe that as well. So it takes a full stack approach. It's risk-based, so our entire standardization process is really focused on providing as much value to the community as quickly as possible and iterating just as quick over time. And finally, there's a lot of security things that CycloneDX does that it supports, not just the very simple vulnerability cases. That's easy. Any SBOM standard could do that. But we go really in depth in terms of our pedigree support. Open source is the ultimate supply chain. Organizations are going to take that open source, they're going to modify it, they're going to rename it, they're going to repackage it, and they're going to redistribute it. And keeping track of that entire pedigree of the provenance of where you got it from and the pedigree in terms of what changes that you've made and who made them and why and when, and does that tie into CVEs that maybe you've backported to fix something? That's all part of CycloneDX today. So there's a lot of other security use cases that you get from CycloneDX that are not necessarily obvious just by looking at it at first. But once you start going down the SBOM rabbit hole, there's a lot of benefit that can be derived from various security use cases just by using Cyclone.
Now, I think the last release of CycloneDX was in May of last year, I think, right? Were there any significant changes or improvements in there? And then is there another release coming up, or what's sort of the future holding for the next revision?
Yeah, no, the version 1.2, which was released was a Q2 last year. That added support for JSON, so we finally support JSON schema now, and it added a few other things. But the one that I'm really proud about is support for services. So being able to describe, if you have like an open source component, and it's just a wrapper around an API, a third-party Google API or Apple API or whatever the case is, you can actually describe not only that software component, but that service that software component actually relies on. Not only can you describe that and the dependency relationship thereof, but you can also describe the endpoints. What URIs does this thing interact with? What are the data classifications going to and from that API? Does it traverse a trust boundary? Is authentication required or not? So that was something that I had to add support for CycloneDX just because it was relevant to my day job. I need this capability in an SBOM. And I know that other folks that are evaluating SBOMs are looking at APIs and other types of services as just a serialization issue. So instead of, having that component, locally on the file system and calling it that way, it's just a remote call. It's just a serialization difference. So APIs are, in my opinion, just part of a software's inventory and should be incorporated. So that was my really big achievement, I think, for 1.2. 1.3 is currently in the works. There's some interesting things that we're working on, some enhancements to some of the copyright things that we support. So we did not come from the specification did not come from the licensed and intellectual property area, but we are making some improvements to that in version 1.3. So that I'm looking forward to that. There's some other random things that we're playing with in 1.3 as well, but there's multiple extensions that we're also developing at this moment as well. We've got an audit extension that allows that we're hoping will allow human auditors to go in and make assertions on what is and is not true about the SBOM and the confidence thereof, all kinds of cases like that. We've got a formulation extension that actually describes how the components themselves were built, what were the sequential and parallel pipeline steps that actually led to the creation of this thing in the first place. And there's a couple other extensions, a hardware extension that we're working on that will enhance our existing support for hardware. So there's a lot of things kind of in the works to make CycloneDX even better a year from now.
That's awesome. Sounds like a lot of good stuff there. All right, hey, I'm going to ask you something to give your thoughts on. PURL. And by that, I mean package URL, so PURL, not Perl, PERL, the programming language. And I may be showing my Solaris age here, but anyways, so what's up with PURL?
I was really excited because I thought I was going to have a really complex one-liner. No, I was doing PURL, PERL. I was doing that type of program back in the early CGI days of the early web. So that brings back memories. But package URL or PURL, PURL, is a really great standard in my opinion. It's an open source project. It comes out of some of the same folks that worked on SPDX historically, but it solves a very fundamental and simple problem. What is the component's identity, and where did it come from? You would think this would be very simple, but it's really not. Every ecosystem, whether it's Maven or NPM or NuGet or PyPI or whatever the ecosystem, they have a different way of describing the exact same thing. And it's crazy. You can't build any kind of scalable security solutions when every ecosystem is fundamentally different. So package URL is a way to standardize how component identity is presented based on the ecosystem it's part of. It also describes, it actually has defaults for ecosystems in terms of provenance, so where you actually retrieve things from. So if I have a package URL that Apache Commons IO and it's from Maven, well, the default for Maven is going to be Maven Central. And if I got it from someplace else, then I can also describe that. So two important concepts, both identity and provenance, where I got it from, is really what package URL is solving today. And it's one of these specs that's so easy, yet so difficult to, I think, get right. And so far, the group has done a very good job in getting it right. The core spec itself is pretty much cemented. The only kind of outliers are some of the ecosystems that we don't yet support yet. But it's being adopted by SCA vendors. In fact, I won't even buy anything in this third-party SCA space. I won't even buy anything if it doesn't support package URL. That's actually a hard requirement for me. So when I'm evaluating vendors, if they don't support it, I simply won't buy it.
What is the relationship between CycloneDX and PURL?
Yeah, another good question. Identity is hard, and knowing what something is called and named and where you got it from is equally hard. And CycloneDX supports, actually since version 1.0, has supported package URL because it is a universal way to describe that. And one of the primary reasons why it supports package URL is there's multiple sources of vulnerability intelligence that exist today, that instead of supplying a CPE or something like that, you can just supply the package URL, which you can get through automation. You don't need human beings to tell you that. You get the stuff free from automation in a lot of cases. And there's sources of vulnerability intelligence that map the package URL back to CVEs or other vulnerability identifiers. So because CycloneDX is a security first spec, package URL was an obvious choice in terms of minimal viable for CycloneDX 1.0. We added support for SWID and a few other things in CycloneDX version 1.2, but package URL has been there from the start.
Sounds good. One day, I'm going to get you to stop always referring to CVEs for vulnerabilities. I swear, it won't be today or anytime soon, but one day. All right. So let's talk a little bit about Dependency-Track. And this is really where you and I met. I think Jeremy, who was running Dependency-Check, different project, introduced us, and you were still on version 1.0 of Dependency-Track. And then I think, you were making great progress to 2.0. So how about this? How about for those that aren't aware of it? And I've been a huge fan of Dependency-Track and your work and trying to tell everyone that I can, but why don't we start with some of the basics? What is Dependency-Track? When did you launch that version 2.0, which I really think where you upped the game dramatically?
Yeah, so yeah, you're right. We got introduced by Jeremy Long through, I think, an email chain way back when. But yeah, I was working on a complete rewrite of Dependency-Track at the time. Version 1 was very focused on manual use cases, describing that server appliance that I had at the time. Version 2 was an attempt to rewrite that kind of failed miserably. But version 3 is really where Dependency-Track upped its game, and currently has about 1 million Docker pulls for version 3, and I'm up to version 4 right now. But yeah, so once you actually have a software bill of material, now what? You have to do something with it, right? Just having a software bill of material, it's like, okay, what am I going to do with this thing now? And that's what Dependency-Track is really about. There's some interesting things that actually happen when you take a SBOM first approach in your development pipeline. There's this interesting power dynamic shift that takes place, because suddenly you're no longer reliant on SCA vendors to tell you what your inventory is. You can assert that inventory through your SBOMs, and then use something like Dependency-Track to consume them and then analyze them. And version 3 of Dependency-Track was really about how to do that, right? How to create a SCA alternative that is really focused on the SBOM use cases. So work on that started in 2017. I think Dependency-Track version 3.0 launched in early 2018 sometime. And it was, to my knowledge, the first platform of its kind that actually took an SBOM first approach. So you just throw SBOMs at it through automation or manual means, and it does SCA-like things where it's looking for known vulnerabilities and whether the components are out of date or not, license compliance, that sort of thing. But it's not actually an SCA solution. It's really about SBOMs.
And specifically, I think one of the cool things is all your work on Dependency-Track sort of led you to the creation of, you needed to do CycloneDX. So CycloneDX and Dependency-Track are really integrated nicely. Is that really the case? Is it easy for people to get up and running?
Yeah, it is. In fact, a lot of the data model in Dependency-Track is modeled, not exactly, but it's very close to the data model of CycloneDX itself. The data model of CycloneDX is really optimized for automation and progressive enhancement. So as SBOMs travel through a build pipeline, you can augment them and you can correct them and you can append to them very, very easily, because the model is very simple. And the model that Dependency-Track uses is equally as simple, because it needs to be able to consume a lot of this information. But yeah, there was literally like this chicken egg problem back in 2017. I wanted to do this thing with Dependency-Track, but the only thing that really existed at the time was SPDX, and that didn't work for me. Security wasn't really in any of their use cases at the time. Now they support a few security use cases that some people care about. But it was this really chicken and egg thing. So if I wasn't working on Dependency-Track at the time, CycloneDX wouldn't have been a thing. But I needed, in order for Dependency-Track to be successful, I needed CycloneDX to be more successful, because I'm asking people not only to deploy this open source OWASP thing that nobody has heard of before, but also to kind of rethink how they build software. And why would I produce this SBOM when I can just use this binary analysis thing from this SCA vendor? And so it was kind of this uphill battle, but at a certain point, the two worlds just kind of exploded. There was a recent there's actually been two recent things that are of interest. There was an IoT thing, a paper out of the European Union that referenced, I think it referenced CycloneDX, but it referenced Dependency-Track as a reference implementation for SBOMs. And then more recently, the Dutch government, NCSC of the Dutch government, actually recommended CycloneDX as their preferred SBOM format for obvious cybersecurity use cases. And they also reference Dependency-Track as a reference implementation for that. So that was two really good mentions.
So I know you were mentioning all those Docker pools and everything that you have, but I know that a lot of companies are using Dependency-Track, and more are, because they keep writing to us about wanting to add VulnDB into Dependency-Track. I've been so impressed with what I've seen, but do me a favor, and I know this may feel a little odd, but if someone is watching this and you wanted to sort of give them the pitch, why would a company choose Dependency-Track over these really expensive commercial vendor solutions?
Well, I think flexibility is one area. Having an SBOM first approach to things not only allows you to evaluate the code that you are producing yourselves, but it also allows you to very easily evaluate the code that you are potentially procuring or acquiring through M&A. So there's a lot of other use cases. I've seen, whenever you create software, you envision it being used in one context, and then you find out that it's used in entirely different ways than you could possibly imagine. I know that Dependency-Track is used to track implantable medical devices in patients. It's used in governments. It's used in financial services, and just all kinds of really interesting places, especially places of where public safety and national security is a concern, which is really interesting. But as an OWASP project, I think adopting Dependency-Track is pretty strategic, because it's very agnostic to the things it supports, right? It supports a lot of free sources of intelligence. It supports commercial sources of intelligence. One of those commercial sources is obviously VulnDB from risk-based security. But as an OWASP project, we're very agnostic, because we know that organizations are using other things, and we want to be able to integrate with those other things.
For anyone that's not aware of Dependency-Track, I urge you to take a look. We've talked about so many things. We'll throw it in the links and stuff in the show notes and whatnot. But I have been really impressed with what Steve and his team have been able to do. We've tried to be supporters. I hope we will continue to be supporters. Just that it is really well done. So. So I know you just released Dependency-Track 4.0. It seems like, I don't know if that seems like a long time or a short time since we met at 1.0. But what are some of the major things? I think I've read, unfortunately, that 4.0 is not a real great upgrade path from 3.0. So there's something different schema-wise that people need to be aware of. But what's sort of the major 4.0 stuff, and then what's up next for Dependency-Track?
Yeah, so to level set, I guess the version 3.x was really about, can this be done in the first place, right? Nobody had done this before. Nobody had taken an SBOM first approach before. And we needed to be able to see if we could create an SCA alternative without actually being SCA. And 3.x was kind of this grand experiment on, can we do it? And the answer was absolutely we could. And I think the number of adopters has proved that substantially. Version 4.x, we're taking a slightly different approach. We're pushing the envelope. So all the 4.x features are, we're going to continue investing in other sources of intelligence, whether that's supplier intelligence, vulnerability intelligence, etc. But we're also going to be focusing on use cases that only SBOMs can achieve. Things that you cannot get from any SCA tool today or tomorrow. So these are some really interesting use cases that I personally am excited for, and I think the market is ready for these types of solutions. So yeah, features that SBOMs can only achieve. And really difficult or near impossible for SCA solutions to achieve. So that's really going to be the focus on 4.x series. One of those features is actually coming up in version 4.2. So in 4.2 of Dependency-Track, we're introducing support for services. So as I was mentioning earlier, CycloneDX can be used to describe those services that your application depends on and all that sort of thing. And in version 4.2 of Dependency-Track, you'll see services right next to the components that you're seeing. And we're going to be introducing that dependency graph, so you'll actually see not only your component dependencies and how they relate to one another, but how those relate to the services that are described in the SBOM as well. So there's some really interesting use cases that I'm looking forward to achieving in Dependency-Track version 4 that are really going to be pushing the envelope of what SBOMs are capable of doing.
I love it. Sounds awesome. All right. I think we're at the end here. So you seem to be pushing the envelope on a lot of things. Is there anything else on your mind that's up next for the DevSecOps or security industry that you're going to want to try to get ahead of and solve, or anything else on your mind that you want to share as we're wrapping things up?
Oh man, I got my plate full now between chairing the CycloneDX core team. We just recently launched an industry working group that I'm really excited for. We're multiple SCA vendors already support it, and a bunch of other folks are hopping on board as well. Bunch of things coming up for Dependency-Track that I'm excited for. So I think my plate's full at the moment. I wish I had time to investigate the attack surface of IoT and whatnot, because that's truly an area that kind of excites me. I think the possibilities for exploit and protections are quite extreme in the IoT space. I wish I had the ability to just clone myself. Seriously, and be able to do all this other stuff, because there's so many other interests in other than just the stuff, the supply chain work that I'm involved with now.
Well, I appreciate all the work that you're doing. I think with your background of working at organizations, having a need, a problem that needed to be solved, and then building software, and not just tools and software, but an approach to think about it. I think it's just been great. Thank you. I know the industry thanks you. And yeah, you got a lot on your plate, but knowing you, I have a feeling that there'll be some more being added on. So maybe we will talk about this attack surface IoT stuff here in the near future. So there we have it, Mr. Steve Springett. I can't thank you enough for being on. Thanks for taking the time to define some stuff. I think this episode is going to be great for some folks, and I have a feeling we'll be talking again soon. So thanks again, Steve.
Very good. Take care, Jake.